All right, so let's get started. All right, so the rational root theorem. All right, all of your possible zeros that are rational come from a very specific setup or a very specific theorem. All right, so you have to remember that a rational zero means it can be an integer or it can be a fraction. This is not something with radicals in them. All right, so if you don't have radicals, it's not called rational. So the whole thing comes from starting with some zeros. So I'm going to show you how we work backwards to be able to get the theorem, because I think it makes it a little bit at least easier to understand like why we can use it the way it is. All right, so what I'm going to do is I'm going to start with just two zeros, and I want to build the polynomial to see what it looks like if these are the two zeros. All right, so you have fractions up there like x minus 2/5 and x equals, x minus 3/4. And so if the first thing I got to do actually to write my polynomial is I have to fraction bust this. So I'm going to multiply both terms of this one on the left by 5. So that way I can get it with integer values instead of fractions, because I don't want my polynomial to have fractions. And the same thing over here on the right hand one. I'm going to multiply by 4 so I can fraction bust that one too. And so if these are my two factors as fractions, then the second row are the two factors without fractions. So if I put those together, I can write a polynomial that has two factors. And if I asked you to, we could do like an area box or something to actually multiply this out. But I'm going to multiply it out for you. And so you get 20x squared minus 23x plus 6. And so what happens when you are using the rational zero theorem, like minus 2/5 and minus 3/4 are considered rational zeros. But they came from looking at how you would find factors of the first and the last terms. So if you look at the way that this second line is built, where I don't have fractions, the first piece of each of the binomials comes from the 5x, and the 4x comes from the 5 and the 4 in 20. It's not the only possible options for factors of 20, but they are two of the factors of 20. All right, same thing with the 3 and the 2. They came from the factors of 6. And so our rational zero theorem basically tells us that if we've got like a polynomial, that the way that we're going to find any possible rational zeros come from factors of the first and the last term only. We don't care about what happens in the middle. All right, what happens in the middle comes from all of the multiplying the different factors. So we just need to focus on those little pieces. And so here's your theorem. All right, so you've got some sort of polynomial, and it's in the format where you have a sub n, x to the n. And that's just a notation to talk about the leading coefficient. All right, so that's a sub n. So that's a is considered like your leading, like any of your coefficients. And we put a little subscript of n so that way you know it's matching the variable that has the same power. Right? And then you've got all these other like terms in between, and then we do a sub 0 to let you know what is the very last one. So the one that does not have any x's on it, we use a sub 0 because it's x to the 0 power. Right? And so that's kind of like this over here, like my 20x squared and my 6. This 20 would be considered my a sub n because it's the coefficient on the leading term, and the 6 would be my a sub 0 because that's your constant. It doesn't have a variable attached to it. So the stuff in the middle we don't care about.
So what if there's like a 5x times 4?
Like inside here?
Yes.
Don't worry about it.
All right.
You don't have to worry about those right now. So all we care about is just the first term and the last term and those factors. All right? And so all of these zeros right here come from a very specific setup. So your setup is pretty much all of the possible zeros, or possible what we call rational zeros. So your possible rational zeros are all of the fractions. We call them P over Q. Right. And the P, these are factors. These ones are factors of your A sub 0. So factors of your constant, your very last term, divided by the factors of the first term. All right, so they're always fractions. And in fractions, you can have a 1 in the denominator as well. Right. And so, but we call them P over Q. It's the way that the rule is written, so that way you can write fractions. And so the first piece that we're going to do is we're going to just make a list of possible ones. We're not even going to actually factor anything right now. We're just going to say, what does the list look like that could be used? Just like up here, like I could use 5 and 4, but I could also use 1 and 20. I can use like 10 and 2. So there's a whole bunch of other possibilities, not just these ones. So we want to make a list of the possibles. And so that's what we're going to do for the first couple of examples. We're just going to list the possible rational exponents, or rational zeros. All right, so when it says you're trying to list them, you're not actually trying to find them. Yeah, Megan? It comes from all the multiplying. So you don't have to work, like this 23 comes from me actually doing like an area box to multiply all those out. So the 23 has nothing to do with how we actually figure out how to factor the first and the last term. It comes from what happens when we actually do the process. So we don't worry about it at all. How did I know it was going to be there? Because I went off to the side before you got here and I multiplied that out to figure out what 5x minus 2 times 4x minus 3 would be. So I did an area box on my own and then just told you what it was so we didn't have to waste our time doing it. So if I want to list my possibles, right, say I give you a function or a polynomial right, that looks like this. So x cubed plus x plus 6. I have no idea what the binomials look like that will multiply together to get that polynomial. But I can figure out what's possible because not everything works. You don't get every number in the book. Right? So what we're trying to do is we're looking at how we're going to build P over Q. Right? So it's factors of 6 because that's my constant term. That's the one at the end. And it's going to be divided by factors of 1 because that's the coefficient on the first term. And so we're just looking at the process or the setup. All I care about are these two right here. You don't care about anything else in the middle. And so now you have to think about factors of 6. And you have to consider both the positive and the negative factors. Because you don't know if you took -1 times -6 or -2 times -3. You don't know what the combination is. So you can use plus and minus 1, 2, 3, and 6. Those are all of the factors of 6, not just the positives, but the positives and the negatives.
Are we supposed to write that?
You do need to write that. Yep. The only possible factors of 1 are positive and -1. That's it. So if I want to list what the rational zeros could look like, all of my possible zeros, where I'd be writing what x is equal to, are all fractions where the numerator comes from a factor of p and the denominator comes from a factor of q. Well, since q is 1, my only possible zeros are these 4. But that's 4 different possibilities that I could have. It's not saying that they are all there, and it's not saying that they're all going to be used, because with a third degree polynomial, I have at most 3 different zeros. All right? So I've got a list of 4 possible ones, and that's it. I don't get any fractions. I don't get any numbers. That's it. All right? So if I can build something like this, it's going to come from this list. All right? And that's it. And so listing what's possible helps you narrow down when we have to start actually doing the division, like the synthetic and checking. It narrows your list down to only having to check those possibilities. All right. So let's look at another one because they do get more complicated. I mean, we haven't even done any of the actual like polynomial stuff. We're just trying to figure out our list. So you got 2x cubed minus x squared plus 6. The same thing. Don't care about anything in the middle. I only care about those two right there. Because when I build my polynomials, it's what happens on the first and the last that puts together my polynomial. The middle comes from all the adding, subtracting like terms. All right. So again, it's P over Q. And so we're looking again for factors of 6. But now I'm also checking that I have to divide by factors of 2. So part of what you need to do is actually list out all of your factors. The factors themselves don't have to be in order, but you got to make sure you have them all. And so now I've got more options of the denominator. So now I'm going to have a lot more possibilities. Right? The more I change the first and the last term, the more options I'm going to get. It still doesn't give me everything under the sun, but it still gives me some stuff. So my possible zeros for x. Right? First, you're going to make fractions where it's all of the possible factors that are in the numerator divided by plus and minus 1, because those are some of your options. And so that's the first set. But now you have to consider other rationals, other fractions, where the denominator is not 1, but the denominator is 2. So now you're making fractions where the numerator comes from factors of 6 with a denominator of 2. So if it's not already listed, you have to list it. So like I have 1/2 as a possibility. Right. I can also do 2 divided by 2, but it's already listed because that's the same thing as 1. I could also have plus and minus 3/2. And then 6 divided by 2 is 3, which was already listed. And so this gives me my list of possible factors now, which is how sometimes you get the ones way up here that were like a 2/5 and a 3/4. That's how those come about, is that they're options depending on what the polynomial looked like in my list. Right? But again, if it's not on that list, it's not a fraction. It can have like radicals and like an I in it, but it's not going to be something that can be written like a fraction. Yes, sir?
So all we have to do is that?
For listing.
Oh.
Yeah. So when your directions just say to list, like this is all your directions are right here, you're just making a list. That's it. So if you're making a list, this is your list. It's basically telling you where to start checking. Because guess what we're going to do now?
Something really hard.
Something really hard, yes. That's what we're going to do now.